Okay, so we're going to keep going over some more shell scripting stuff here. And let's have a look at what we got. Now last time we went over some of the if statements and the for loop and the while loop and the until loop. But the one we haven't gone over yet is the select loop. So that's the only loop we didn't cover. And I'm also going to go over sed here after a bit. We're going to have another class where we spend a lot more time on the shell redirection stuff because that's really important. It's very important, matter of fact. Here's some of our other scripts we wrote. Now, we have a couple of different ones we choose from here. Now remember, this is back on chapter, I think 28 or 27, one of the two. Yeah, I think it's 27. Yeah, 28 is Perl, so yeah. 27 it is. And let's look at the select loop here. And then I'll break down regular expressions as it applies. I have a whole video on regular expressions with sed that you will have access to. It's very useful. Alright, so select here is on 999, literally. 999. It's quite humorous. It is a big chapter. It's 100 pages, yeah. So if I look at this, this is kind of cool. We can do a series of options that people can choose from. And it's pretty cool because eventually what happens here is that we can do a test on this stuff. And this basically creates menus, more or less, with the select loop. The select loop's pretty cool, actually. If you consider it versus some of the other tools there. Matter of fact, if I actually just start typing, like when I want something here, it'll automatically put me right here for the search bar, which is nice because then I don't have to go hunting for it, you know. Yeah, basically the select loop creates menus. So they have an example here, fruit 2, which looks stupid, and it is. It's not something you would use normally in real life. You wouldn't create a loop on fruit unless you had a fruity person have you write. I don't know, dude. Anyway, it doesn't make much sense to do this, but whatever. This is their example. I tell you what, I'm going to change it up to where it does make more sense. So, I just don't. I hate doing fake stuff. I can't stand it. It drives me nuts. So, we're going to do something real world more, because I definitely have a preference towards real world stuff. All right, so it's called select Linux.sh. Alright, and so you can imagine how you could use this with the other one that we had here, and not to mention the future scripts too. So this is cool because this will be straight up and down, no joke, something you will use. So that's really nice. So I have a message here. We can store it. Let me think. How do I want to do so? Linux version. Alright, Linux version message. How about that? Ooh, yay. Really long variable name, but hey, we know what it is, right? So, choose which flavor of Linux, helps if you spell Linux correctly, you want to use. Alright. Something like that. So now it's going to store that value. Oh, and by the way, there's no spaces here for this equal sign. Why? Because we're doing an assignment. Anytime we're doing an assignment, no spaces. If you do spaces, wow, it's going to be a problem. This is an extremely strict rule set language. Out of all the languages I know about 30 programming languages. This is the most strict programming language of all of them I can think of. It's just, we'll get into here in a little bit regular expressions, and you'll understand why you must have spaces around the brackets when you're doing the if statement or the for loop, because it means something completely different if you don't do that. And so that's the thing about shell script, is it reuses stuff like crazy. And so then spaces are actually part of the language, and so since spaces are part of the language, it actually matters whether or not you put spaces around something. So it messes with you. It really, really does. If I do select here, and then in here I can say whatever I want to name this variable. Now I'm going to call it Linux distro for distribution. Does that make sense? So I know which Linux distro I'm working with here. So I'm going to loop through here for my select statement. And then I'm going to check in, and then I have a different ones I can select from. Now I can do something like Fedora for one. I could do CentOS. Is this making sense? Ubuntu. I could do Mandriva. I could do SUSE, etc., etc., etc. I could do Yellow Dog Linux for that instance. Yeah, Yellow Dog's another one. It's real popular on the Mac. But okay, so we got those different ones. And then I do like the stop here, saying that, hey, we went to, we're not interested in any more choices here. Now, I can then say do. And, if you wanted to, instead of doing Linux distributions, you could do something like what kind of server you want to set up. You could have a script for setting up LDAP. You could have a script setting up NIS, one for setting up NFS. You could have one setting up Samba, one for setting up Apache, one for setting up LAMP, MySQL, PHP, etc. inside of there. You could have it setting up a DNS server, etc. And so you could have these different categories here where you could literally select what server it is that you want it to set up and install. You write a script that actually sets up and installs that server, and then it runs that part for running that script. And my suggestion on doing that stuff, if you are going to do that, is to have each one of those servers as its own separate script, and you call those scripts from inside of the master script for each one of those servers. So that way you can separately maintain it and keep it all concise and confined, and that way you don't have this thing that's like 10,000 lines long or something like that for one script, because that's just nuts. So breaking things up in the files make a lot of sense. But if you wanted to do something like that, you could do that instead of like Linux distribution flavors here. Because I wouldn't typically loop Linux distribution flavors. It really wouldn't make sense to do this for a Linux distribution. I'll tell you what, since it wouldn't make sense, let's switch that up. No, I'm already doing it. Never mind. I'm already doing it. Let's just go to the path here. Everybody's like, thank God, he's getting ready to change everything. I'll do the other one just as an example here after this, okay? Because it's more realistic than this one. $sign here, and it's going to be Linux distro, like that. And then we're just going to test to see if they typed something correctly in there. And what they typed in here should be something other than nothing, right? I think we can all agree on that, or at least we hopefully can. Because if you're typing in nothing, that's not very good. That's not a good practice, matter of fact. Alright, so echo here. And we need to let them know that their entry was invalid. So you typed nothing. Try again. Alright. They're getting a little testy about it, but hey. Yeah, we can even detect when they do nothing at all. Continue, remember, skips the iteration. So all the rest of the stuff down here, if they type nothing, we're going to skip it. Makes sense? And then else if they typed in $, fruit, not fruit, Linux distro right here. And if they have it equal to stop, then it is something like echo terminating program. The program terminator, yeah. Come with me if you want to quit. Alright. So here we go. We're going to break out of that loop. Otherwise, it's going to be an infinite loop. We're going to spell if backwards because we're ending this loop because that makes total sense. And we're going to come down here. We're going to spell done out because we're done looping. Because remember, you do it till it's done. Now, something we're going to do here before we're done. Ha ha ha. But no, literally. And that is we're going to type in here echo. And not the dolphin variety, but right. Let's see here. Okay. We're going to say choose your Linux. I'll give that a capital L. That's an important thing there. Linux. Oh no, sorry. You chose. So you. Okay, my little finger's getting too happy here with the typing. I'm sorry. You chose $Linux distro as your selection. And then basically we're just showing what they have chosen. Now, in all reality, you would keep doing these if tests, and you would do something based on whichever one they selected, right? So that way you can then make it run that server for that distribution of Linux, which makes sense. So that's what you would do in reality. But then again, it doesn't make sense to do that in loop, just in an if structure. Well, I guess you could do it in a loop until they got it right, you know. So if they kept getting it wrong, it just keeps repeating over and over again. Keep asking them what they want to do. So that's the other thing you could do is you could actually test to see if, hey, are they typing it in wrong? And that right there would be the reason why you might want to use this as a loop, and in which case this is a valid and this just shows an example of the reply variable, which is nice. That does that, and there's our in. So I'm fine with that. That's cool. And then we come down here. We're going to say exit 0, of course, and we want to do an exit 0 so that we let everybody know that hey, the program ran perfectly fine. All right, so I'm just going to pop over here real quick, and I'm going to select the other desktop. I'm going to type in terminal. Don't worry, I'm coming back to the script. Some people are horrified at me already. Day just got started. Alright. I'm just going to come into the scripts folder. Yes, I am. We are being recorded here. So, one thing I can do is chmod plus x space, and then let's just make it executable for our brand new happy script here, which was Linux distro, which is starting to make me wonder where on earth I saved it, since I'm not seeing it here. Select Linux, and it's inside of scripts. Awesome. Okay, so I'm not crazy then. Where? Oh, there it is. I overlooked it. Oh gosh. Alright, there we are. That sounds like something I would totally do. All right, select Linux is executable now, so I can just do this // Otherwise, I have to type sh in front of it, which works too. I can do it either way. And bam, there it is. So it's asking us what we want to do. If I say 1, Fedora, it told me that I chose Fedora for my selection and what number I chose. And remember that reply $reply is actually telling me what number it is, because that's actually getting down which one they selected for a numerical value. Whereas earlier when I said Linux distro, whatever value they selected from the list there is what's getting inputted. Does that make sense? I don't really have to worry about someone mistyping something when we do it in one of these loop lists like this, because they just literally choose the number from the selection list here. So that makes it easier for someone to get it right, which is the way we want it. If they want to stop doing this program, they simply say 6 to terminate that program. So that's cool. All right. Now, one of the things I would want to do with this little message here is I would really, or should really, want to echo out that message every time we run the program, preferably at the beginning of the program here. So if I echo it out, let me see something here. I'm going off the script now, and I don't care. All right. $sign Linux version. I wish this thing had auto completion. All right, something like that. I can get away with that now. I'll put that inside the loop, ideally. Yeah, it totally didn't. Well, what's ideal and what it does are two different things, apparently. So in this case, it chose CentOS instead. 6. I did save now, didn't I? Let me just make sure I did save indeed. I'm not losing it. Okay, so it did do it, but it did it at the end, which is not real helpful. Alright, yeah, that's not cool. Choose which flavor of Linux you want to use. So it did put it in there, but it's put it in after the fact. That's problematic. Alright, so something we could do is we could echo it beforehand. The problem is every time it displays this thing, it's not going to show that message where we want it to anyways. So up here, and then we'd have to put it down at the end here where it asks them, you know, all that fun stuff. And I'd have to put something like an echo in here and or space it out. So what's going on here? Well, I need to display the message before the loop. So by putting this variable in here, I can basically repeat this message without having to type it all out multiple times. So that's the point of having this variable here. We can store a message in there. So it makes a lot of sense. Otherwise, you're going to have to type that whole thing out multiple times, if you will. It's a little more efficient. It's a little easier on you type deal than not. So that's nice. So once I make this variable where it has this message, I can just repeat this message over and over again. And by doing this right here, alright, so now check it out. Now it says choose which flavor of Linux you want to use. See that? It says it beforehand now, which is great because that's what we want, right? Say I want to do Mandriva. Alright, so now check it out, because the way I did the spacing and everything, and where I put it, now when the loop repeats, it asks me choose which flavor of Linux you want to use. So now it's going to ask me that question every time at the prompt here. Does that make sense? So it's pretty cool. That's pretty cool. In this case, I want to do 6. All right. What's another way we could use this exact same idea? And the cool thing about using scripts is you can feel free to copy and paste. Why can you feel free to do that? Because it means you have to do less work. So let me show you the wonderful art of doing less work. So we're going to do that like so, and then we're going to paste it like so, and we're going to save it. Instead of doing select Linux, we're going to do select server. How about that? Yeah. All right. Select server it is. All right. The moment I do that, bam, I get all my highlighting. Now, you can say choose which server you want to set up. All right. And I could change this to server message. I like to do that. Yeah, could I use the same variable and it would not matter? That's true. That would be the case. But in doing so, it's annoying because now it doesn't make sense throughout the program. So I like to go back and rename those variables if I do change something like this, because it does then make it easy to understand what on earth we're doing. I'm just going to call the server, and this will be the server variable to let me know which server it is we chose to do. And the rest of the stuff doesn't really have to change. Check it out. Oh my gosh, it's the same. Except for this one part here for our select, because we do need to change this from Fedora, blah, blah, blah. We get to use our stop still, but we could do things like DNS here. And we could do things like NFS, NIS, LDAP. We could do send mail. We could do things like, or we could just call it mail if we want. We could sit there and say send mail versus postfix for our mail servers if we had them both set up. Things like that. We could do FTP, SSH. Oh, sorry. No, we need to do VSFTP. And can't just type SSH because that's literally the command. So that's the issue there. So SSH server. I don't know what else to say on that one, because if I do, so on and so forth. DNS, NFS, NIS, LDAP, SendMail, FTP, basically SSH. I could choose postfix, for instance. I could choose. I could do a LAMP server, which is Linux, Apache, MySQL, and PHP. So there's that. I can keep going here. I could do Dovecot, for instance, for the receiving mail server. So on and so forth. I can keep doing all these different servers. Yeah, you guys have a lot to look forward to. As you can see here, you got a lot of servers to learn. Not in this class, but in the next class. Now you will end up learning LAMP, and you will learn FTP and SSH in this course. But as far as the others go, no. So this is just an example of the different servers you could have, for instance. There's more than this, but that's just sampling. Oh, I got to throw Samba in there. That one's important. So Samba, for instance. So the cool thing, like I said, is you could have these different ones right here, and then it runs a script. And I'll just put this out there. And let's just go ahead and break it before we even get to the rest of them. So that's going to be higher up in the chain of command for as else ifs. So we're going to do an LF here. And I'm simply just going to do a $server again here, equals. In this case, I'm going to choose one of these now. Let's say, for instance, that we do SSH, which would be extremely simple. One to choose, _server. So otherwise, this is a command, right? So it makes sense not to make it into a command, because that would be a serious problem if you did do that. Here, say in quotes, installing SSH server and setting it up. Now, I wouldn't have to necessarily do this echo. Instead, what I could do is say sh, like this, and then I could have the script in here already, right? And this could be the ssh dot sh script. And this script would then install and set up that server. Does that make sense? Do this another way, take this another way. I could come in here like so, literally, do this again, because I can be lazy about it now. Ha ha ha. Change that to something like lamp. Now I've already set up one for lamp. And I can come in here and say lamp. They're really happy next door. Alright, so from over here I can say something like lamp2.sh, for instance, and that's literally going to set up that lamp server, right? So, in this case, I don't have to go in there and literally have this massive script that covers everything for every server. Instead, I can just run the script from inside of this script for doing that other server, and thus I'm calling that other script. So just as an example here, see, we got DNS, we have sed, etc. So we do have a DNS one. We also have an NFS server. So we could have done an NFS server if you wanted here. Here's our LAMP2 one, right? And so literally this whole script is going to run with this one little line right here. Pretty cool, huh? So that's really nice, because now we don't have to sit there and come in here and I don't even have to do // I can just get away with that right there, matter of fact, since this is sh. So now I don't have to have all that code right here. Otherwise, I have to put that entire code inside this else if, right? That would suck. We don't want to do that. That's work. So that's not cool. We're like, yeah, well, we know your thoughts on that. It's not so much a matter of being lazy or whatever. It's a matter of getting things done in a decent time frame, and that's the big problem, big question here on a lot of this stuff. I joke around by saying laziness or whatnot, but in all reality, you need to get things done in a decent time frame, and just so you don't have to worry about stuff. For instance, if I wanted to do this whole routine here for setting this up, I can actually call both of these scripts here for setting up an NFS server and call them in succession from the other script, and that will set up an NFS server. I can come in here on another one, for instance. I could come in here for, see, that's the thing, I've written some of these already. This is not in your class, but well, here's one for DNS. It's unfinished, but yeah, it literally sets up a lot of the DNS stuff here. And if you were to get real enterprising about it, you could even have it ask them which type of DNS server do they want. Do you want to do a master or slave? Do you want to do a cache-only server? Do they want to do etc.? And so you can mess with that. So this is pretty cool. You can get an idea of just some of the stuff you could do with this, and this can be very powerful. Open LDAP, Samba server. So this will literally set up a Samba server. I've been working with particular users and all that stuff. So I mean, I could literally go in there and just do Samba server for the script, and lo and behold, it would do it if I ran it, which I probably would want to. So again, the only thing I would have to do to get that one going is just pop that in there like now, and then come in here and say Samba. So hopefully this is starting to hit home. Wow, this is pretty powerful, hey, I can write these things as separate scripts. I don't have to put it all in one place. That's what we don't want to do. Not that it's bad, it's just that it gets unmanageable. It gets harder to code it. The more code you get in something, the harder it is to find what you're looking for. The harder it is to troubleshoot something. The more you can modularize or break things down into pieces, the easier it is to actually fix something or make changes to it. You can reuse code more easily. So I can sit there and put this in a whole nother script for these other servers here. Doesn't necessarily have to be in the selection one here. So now I can sit there and reuse them more easily and whatnot. So the more you break things down into the parts, the faster it is you can debug them. If you want to get real crazy about it, I can sit there and have where I ask what type of Linux they use, and then reuse that little script where it tests which Linux version they use for every single script that you have for all the servers. Does that make sense? So now I only develop it once. I only have to fix it one time, and then I just call that script from any other script that I want to use it in. Ta-da, I'm done. And that's where you're working smarter and not harder. And then your chances of, and then say you have some mistake and you catch it, right? You only have to edit it in one place, and now it fixes it for all the servers that you included that in. Ta-da! Makes sense. It really makes a big difference when you start thinking this way. So breaking things into modules or breaking things into pieces like this and into separate files, and it makes it easier to read it, makes it easier to manage it, makes it all that stuff. It makes it easier to think through the problem too, because you have less to think about. You only have that one piece to think about. Hey, let's make that piece work, and then I'm good. I don't have to worry about it again. And then if you have a problem later on, guess what? It's not any of those other things you made sure it worked earlier, right? You can basically just take them off the table. They're not the problem. It can only be the new thing that you wrote that you're messing with that has to be the problem. And it can't be anything else type thing. So it really reduces your troubleshooting time frame and lets you just knock things out a lot quicker, and it'll actually make programming way more enjoyable if you do it that way. If you try to sit there and like write everything all at once and go, all right, let's see if it works. First off, chances of it working is so daggone slim, it's not funny. You would never bet money on it type thing. Because regardless of how much you think you're flawless or whatever, you're probably not. Especially on this language, because remember, just a space would throw you off type thing. All right. So, and then the other thing about it is that that's a lot of code to go through. So you're probably going to have logic errors through it, and it's going to be a pain in the butt to find whatever it is you made a mistake on, because you're going to have to go through all the code to find it type thing if you do it that way. So there's different ways of working, and this is a smarter way of working, if you will. Does that make sense to everybody? All right, so that was the select loop, and also some practical application of how to use it. If you want here, I'll show you real quick running that program we just made. And that was a really simple, short program. Wow, that was a short little loop there. Really didn't have much going on in it, but it really had a lot of power. And again, that's because we're calling these scripts. So chmod, I'm going to do a +x again. I don't have to, but I'm going to. And then I'm just going to do select server here. I'm going to do a // here, select server .sh. And there we are. Now we have all these different servers to choose from that we want to install and set up. It's cool. It's very cool, in fact. And I could come in here and I could choose NFS, for instance, or I could come in here and I could choose something like Samba or LAMP or whatever. I got my choices here. So I do LAMP. Check it out. Now it runs that script within inside of this script. It's now asking me for which distribution of Linux I want to install and set up. Do I want to do CentOS? Do I want to do Ubuntu, etc.? So very cool indeed. This is the older script. I really don't want to do all this, so I'm going to go ahead and exit out of it. So obviously I wouldn't want to do LAMP 2, I want to do LAMP 1. I chose the wrong one. LAMP 2 was the old one. I did it as a backup for 2. So instead I want to get away with just... And so I found that problem, and I just come in here and do that right there. Ta-da, fixed. Very simple. You can start to see how easy this is to manage this. There we are. Again, I could choose 9, and now it asks me if I want to do Fedora. I could literally type in Fedora. And then now it's asking me for the root password because it's going to change over into root because I wasn't root when I ran this. Of course, it's going to be password. So now I'm root, and now it's, of course, exit out of the program, because the moment you change shells for root for the user, you're going to automatically leave whatever program you're running, because you just literally logged out and logged in. Anytime you log out, guess what? Your program's closed, right? Same thing happens when you're in Linux on the shell here. You're like, oh, no, that sucks. Yeah, well, that's what it is. You log out of a system, you're out. So whatever script you were running isn't going to continue on into the new user that you're going to become. Does that make sense, everybody? So be aware of that. And then here I'm just doing it again. I'm just going to say select server. So I even have it built in there for how to detect whether or not someone's root. So that's something I could easily break out as another script, and then reuse that anytime I like for any other script. That's great. All right, so in this case, I'm going to do, let's just go ahead and do lamp. So it's going to ask me here, and I can say Fedora, enter, and then it would go and install them. Now, it's not going to work because I'm not connected online, but it's literally going through all the install processes for the script. So, and of course, if it could find it, it would do something. It would literally go in and it would install the LAMP server for me. And I can even have it go in and even edit the actual configuration files if I wanted to. The thing with inside the script. So I could literally have this thing where it just sets it up, the server, completely, and I do nothing at all as a network admin. Which is beautiful. Let me tell you, that's the way you want to do it. And you can even have it ask you questions. Say you want to do custom input or something like that. You can actually have it ask you questions. You answer those questions, and it automatically edits the configuration file for you. You code it up to do that, so don't get me wrong. You have to know how to edit the configuration file to make it do what you want. But the thing is, it means you make no mistakes. You can even remind yourself what the options are in your own script for what the configuration file is. So very, very powerful and very cool. Can really make your life a lot easier. Because a lot of times what you'll find when you get on a job, you're going to set up the servers the same way. You're only going to make slight changes here and there for whatever setup, but you're going to keep using the same setup over and over again. So if you write a script to automate that, you can actually do hours of work in a matter of seconds or minutes. But in order to do it, you have to know how to write these scripts to do it. So this saves you a lot of time. A whole lot of time. It makes you more valuable. Without a doubt. As an employee, it definitely makes you more valuable. It's not always easy to write one of these, but in doing so, if you do write one, wow, man. But here's that script we just ran from the other script, and you can see it. It's going through here, and that's the OS version. But the next one here down here is Fedora, and it's the same thing pretty much. This is how we detected whether or not they were root. Here we are. Awesome. Again, I could break that as a separate process if I wanted to. And then here we see all the different installs happening. And I can put these all in one place so I don't have to worry about it for my LAMP server. And then my LAMP server is just launched and it starts right up. And this even adds in the PHP info so I can even see what PHP info, what PHP modules are installed on my LAMP server after the fact. And I can test it. That's crazy. That's awesome. That's what we want though. So on and so forth. Here I'm testing whether or not they are root. And then I'm telling them to enter in root, which we just ran into. And there it is. Again, I can reuse that. I'm putting it directly into these if structures here, but I don't have to. I could write that as a separate script and then reuse it in every daggone server I'm using now, if I wanted to. So that would be smart. It means less work, and it's called that script from inside of this script. Why not, right? So sure, we're going to have scripts called within scripts inside of scripts, but that's fine. It's no big deal. It just breaks things down, makes it easier, and it means you have less problems and less issues. So there's definitely some serious benefits to doing this this way. If we look over our poor little script here, it's still trying to find those servers. We're not connected to the internet, so it's never going to find them. But it's certainly trying hard for our sake, as far as that goes. I'm just going to go ahead and kill this so to help aid help deal with its frustration, because I'm sure it's a very upset and frustrated script right now. I'm just going to go ahead and exit out of this user. Fine. What was I don't remember. Control C. There we go. Now we are student again. Awesomeness. Alright. Control C will kill a program most of the time. Not always, but most of the time. 90 something percent, more like 99% of the time, but not quite. Maybe a little less than that. Somewhere in there. Not real exact. It's in the upper areas, the 90 something percent. It does it for almost everything. Not quite, though. There's like one you have to use something to say Control C. You have to say Control D for one of the programs. I can't remember which one it is. It's really, really rare, but it's only like one program I can think of that makes you do that. Anyways, so hopefully you found that cool and useful, and that's really more in line with an actual real-world example. I love doing real-world examples, and that's certainly the case right there. Speaking of case, that's the next one that we need to look at. Is the case statement. Now, a case statement is going to be on page 1004. And we need to do case and ESAC. ESAC is case spelled backwards, which lets you end that script. It's nice and stupid. That's the way we like it. Alright, so from here, we can do a whole case statement. And a case statement is like a list of options of things you may or may not want to do. It all depends, right? So on page 1004, this is actually quite interesting what they set up here. Remember what the $sign is for a variable? This is what actual arguments they're passing into a script, right? Remember how you could have different arguments, and in our case, we could have something like Fedora or CentOS or Ubuntu being passed into the lamp.sh script, right? So instead of doing that, they set it up. Well, I mean, just like doing that, shall I say? Put it another way, they test to see which argument was passed in. Was it 1, 2, 3, whatever? And depending on which one it was, depends on how they handle it. So a $sign means how many arguments, shall I say? Let me rephrase that. $1 would be the first argument, $2 would be the second argument, so on and so forth. But $pound is the number of arguments. So here we're seeing where they are testing how do we handle the program when we have 0 arguments? How do we handle the program when there's only 1 argument? How do we handle the program when there's 2 arguments? How do we handle the program when there's more than 2 arguments? So on and so forth. So that's pretty cool. And that's an example of using a case statement right there. And put it another way, case statement doesn't have to be based on numbers and characters only, like it is in every other programming language. Every other programming language requires it to be an integer or a character. That is not the case for a case statement inside of Linux Shell. It can be quite literally anything, and it will work. You can do an entire string, you can do floating point, you can do whatever you want, and it'll freaking test it, which is crazy. You wouldn't think that it would do that, but it does. So, let's see here. That's the best way to put this. For instance, I don't know. How about declare-I space num1. And you do the $! Exclamation mark / bin / bash, like so. I'm going to do a case statement here. Hold on a second. Case. Alright. This is a really stupid one, but it works. Alright, so I'm using the declare-I. And the declare-I makes this into an integer variable. Now, by default, when I create a variable, it is string, type string. But if I do a dash I here, it actually makes it into a number, and I can actually do mathematics on it. Does that make sense? Well, if it doesn't, I'm sorry. Dash I. An integer would be the same thing as a whole number from mathematics. Meaning 1, 2, 3, 4, 5, no decimal place, right? That'd be a real number, or aka a float. A real number and float are the same thing, okay? So be aware of that. But let's call this one sum, so we have the sum value. Ha 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 ha. All kinds of nice dorky programming jokes. Now you can make these too. You don't have to limit just to me. Now if we come in here, we can say here sum value. This is getting more and more fun as we go along here. Sum value equals num1 plus num2, for instance. And then I'm adding those together, right? But before I do that, it'd probably be a good idea to set num1 and num2 to some kind of value. I'm just saying, that's probably a good idea, right? So let's do that while we're at it. Let's say num1 equals, I don't know, what do you guys want to be, 7? Awesome. Glad everybody could choose on that one. All right, num2 is going to be what? 8. Good job. All right, so from here, we're going to come down from here, and we can do our case statement from this here. So in this case, another one, we're going to say some value in, it just gets more fun as we go through these different choices here. Some value 10, for instance. So if we get 10, value 10, we're going to say, I don't have enough. Wow, this would be a really stupid program, but I don't have enough apples, because that makes total sense, but no, it doesn't. But whatever. You know, whereas if I got a totally different one to choose from here, now if I come down here, I need to do a double semicolon there. Why you do that, I have no freaking clue, but that's what you have to do. That's what they require. Just so you know, that's what's required. And you're thinking, well, hey, we wouldn't possibly do. We need to close that parentheses. Not when you're doing case statements. You never close the parentheses. I'm sorry. You always close the parentheses, but you never open them, which doesn't make any sense. I know. I understand. I completely understand. But that's the way it is. So, you know, that's what we do. Echo. Have too many apples. Yeah, that's dumb. All right, so I'm gonna do a double, a double. And I guess echo. I don't know how many apples I have. Now that's really stupid. I apologize for such a stupid script here, but whatever. It still teaches you how to do this thing, but it is really dumb. I ain't gonna lie. So I'm gonna do ESAC right now, which is case spelled backwards, right? Because just like if, when we spell if backwards, it ends the if statement. Same thing for good old case. So you spell case backwards. So if you look, we have ESAC, so that'd be ESAC or ESAC, if you will. And then of course we're going to do an exit space 0 like so. And end that. Alright. So can anybody tell me what this stupid little script's going to do? Someone says it's not going to give us anything, and someone else said a formula? Okay, I think you're both wrong, but that's my own opinion. Let's see what happens. Yeah. So let's see what happens here. Alright, let's chmod again, plus x space. And then let's just do a case here. Nobody knows what it's going to do. Let's find out. Oh my gosh! I don't know how many apples I have, and I'm even surprised because I wasn't expecting that. So he was right. Aha! So I was wrong. How about that one? Alright. Not real sure why that is, but alright. Well, num1 and num2, the case should be 15. 7 plus 8 is 15. So I figured I would have too many apples, but instead it told me I don't know how many apples I have. And I agree. At this point, I don't know how many apples I have. And I'm trying to figure out that one myself here. So let's see what's going on here. I don't know what's going on, man. Hit save. I thought I knew what was going to happen, but apparently I got a little surprised there. Means everything. Yeah. So it did come up. Okay, this is real fun. So it was 15. How about that? It was 15, but it didn't select 15. Then it'll do nothing at all. Right? Because it still didn't choose 15 no matter what. Right. No, picks it last because it's the last one in the order. It does it sequentially. It goes down line by line, so it does that one last. That's what I'm wondering. Why isn't it selecting 15 since it is 15? My only guess here is that it needs to be a turned into a good old string of text for it to evaluate it. Which sounds stupid, and I agree that not only does it sound stupid, but I like to think that it is stupid. Alright, so let's make a new variable called sumText for our sum value, right? And let's put inside of quotes, like so. Let's put $sign here and say sum value, like that. And the reason I'm doing this is I'm trying to convert this into text. Does that make sense? Let's see if this suddenly... My thought here is that it's automatically basically putting quotes around these numbers, essentially, in here. And I think that's what the deal is. And so that's why it's not getting evaluated. So if I do this right here, essentially I'm taking a value and I'm turning it into text by putting quotes around this. So here I'm accessing the value inside of some value, which is 15, and I'm putting quotes around it, which makes it into the text 15 now instead of the number 15. But again, this does have to be integers up here in order to do the actual mathematics, because you can't add a word to another word and expect to get something else. You know, what's Sam plus Jill? I don't know. Relationship problems? I'm not sure, but but it's not going to give you a number. That's the point here. And I still don't know how many apples I have. All right. Wow, what a crash and burn example. Awesome. Did I remember to save? That's the other question. All right. Otherwise, I'm getting really impressed with myself. Okay, yeah, no, it totally crashed and burned. Great, good to know. All right, so a different example then. One that I can actually make work. Since this one apparently doesn't work well for integers, and I'm really shocked at that. I am really, really freaking shocked. Wow. Okay. Never tried to do an integer in this case statement inside of shell, and now I know why. Let me change this whole thing up now, since it's going to do stupid stuff. All right. How about we do this? How about we say echo all right, so let's do this. Tried and true, yay. Let's do read Linux distro. Going back in this direction again. But we're using case statements instead. Now in the past I have actually done this case statement in place of the lamp one here. So if you guys want, I could literally come in here instead of doing these else if each time. We could do this as a case and as a case statement here. And it works. I've done it before. The other thing you could do is remember, I also have done in the past too. Remember that for loop where you could have different things that you want to do it in a list? I've actually put every server I wanted to install in that list and then called that variable in my for loop, and it went through and installed every one of them. Because I made it do this yum install space -y for each item here on the list for the for loop, and it's literally would go through and install every server one after another after another after another in the for loop. That's another thing you can do on here. I'm just pointing out different ways you can write this stuff to make it do different ways. I like this method here because it lays it out and makes it easy to read. I mean, yes, I could do it in a for loop list, but it makes it harder to read it. That's why I don't like it. But can I do it that way? Oh yeah. It is cool. It is more techy, more nerdy way of doing it, but I prefer that other method I just had up there because it does make it. All right. So I should be able to come and say like Fedora, for instance, and it's pretty cool when we do these here. I know they have more case examples than just that one little case statement there, or it should have anyways. Do they not? Wow. Talk about. Alright, it's got to be on another page somewhere. Alright, Fedora. I know they do. There's even a trick I haven't shown you guys. Alright, I'll show you in a second here. Fedora. You know what? I'll do it right now. You can even do this. You can do a vertical bar, which means or. And you can do that like that. So it could be either Fedora like this or Fedora, the capital F. Make sense? Right. There's some other tricks too you can do. Ubuntu, etc. Something like that, right? And then I can have it be happy fingers. All right, and then I don't know. How about I don't know. Sorry, my finger keeps barely touching the or hovering over the little mouse pad here. It's driving me nuts. Wait, that distro distribution of Linux. For instance, so if they type in anything else, it says, I don't know that distribution of Linux. All right, assuming I haven't gotten something terribly off and wrong, it should be a. Oh, gosh, I wish it'd stop doing that. So I need to do that, right? Okay. Yep. So there's an example of case working. One other thing I would need to do is put that -n in here, because that's really annoying with it going to the next line like that. My mistake as far as that goes. But so now we're setting up Ubuntu or Ubuntu or however you want to say it. And there we go for as a case statement, and that's how it works. Since I could even run this, and I'll even prove it to you. I can even say Ubuntu like that, and it still selects it because we got that or vertical slash in there. Okay, so very important, very cool. Now you'll notice that that or vertical slash is completely different than when I'm redirecting input, right? Because I remember I can redirect commands, and that still works. Now I could say something like cat, I don't know, lamp.sh, and then I'm going to redirect that into grep, and then something like that, right? Well, notice you're like, oh my gosh, that's the exact same thing right there as what's up here. How does it know the difference? No spaces. That's how it knows the difference. I'm not kidding you. That vertical slash does something completely different when you have no spaces around it versus when you do have spaces. When it has no spaces, it's OR. It's a bitwise OR operation. When it does have spaces, it's file redirection. It's literally redirecting stream input from one thing into another thing, to another program. So be aware of that. Same thing for the brackets. We've been doing these if statements and whatnot with the brackets. They mean something completely different when they have no spaces versus when they do have spaces. We'll get into that in just a bit here. All right, so we've gone over select, we've gone over case. We need to do array variables. Oh boy. Arrays in Shell are truly ugly. They're the ugliest implementation of arrays I've ever seen in my life. So, hey, /bin/bash. How many of you guys are familiar with arrays? Awesome, nobody. Okay, so from here, let's do an array. Array.sh. Now I could also put those installations in there. And maybe that's what I should do for my array. I don't know. Maybe I should. Maybe I shouldn't. It's all relative, right? Why not? Sure. Alright. So there's different ways of doing this, and different ways of doing this. Some will drive you more nuts than others. But not to beat a dead horse, but Linux distros, how about it? Not Linux distros, I'm sorry, servers. Let's do servers. Servers sounds great. I want to do servers. Alright, so I'm going to do a server. So an equal, and I'm going to say what servers I want inside of here. Awesome. So I might want NFS, NIS, DNS. Why? Because they're all little short 3 ones. That means I have to type less. I'll throw a bigger one in there. Samba, lamp, etc. I mean, I could keep typing, but I'm not going to. I'm too lazy. Alright, so it gets the example across. That's what's important, right? I'm going to do this almost as a per example thing here. Now, something I want to point out here with this, and they did their variable. This is a single variable, but it stores multiple variables in it. So think of it as like a container, and inside that container, it holds other containers. So, for instance, maybe it's like a desk drawer with boxes in it. Does that make sense? All right. Or if you want, you could think of it as like a dresser, and it has different drawers in the dresser, right? So the dresser contains those drawers. That's another way to think of it. So each one of these here these are the values. They're getting assigned to the different array variables with it, and each one of these means another array variable is being created to store that value. Does that make sense what I'm saying? So this means there's 1, 2, 3, 4, 5 array elements in this array. We call them elements to represent the different variables stored inside of the array variable. So essentially an element would be like, and it starts at 0 and goes up from there. So the computer always starts counting at 0. So let me give you an example, for instance. Say I wanted to access DNS, right? You're like, well, that's number 3, right? Server. So you're probably thinking, well, dude, that would mean I would need to say, 3 in there to access that third element, right? DNS is the third one, right? But no, the computer starts counting at 0. So subtract 1 from what you think it would be. So it starts saying, so NFS is 0, NIS is 1, and DNS is going to be 2, Samba is going to be 3, and LAMP is going to be 4. I'll prove that because I can. All right, so I'm going to say echo here. I'm going to say $sign. I'm going to say curly braces because we're accessing an array. So we got extra weird stuff happening with this whole thing when it comes to all this good stuff. All right. So there's exit. There's echo. And let's go ahead and run this. sh array.sh. I'm too lazy. I don't even want to type thing. Oh, look, it says Samba, right? Because I said element 3 was going to be Samba and not DNS, even though you had thought it would be the third one. Actually, when I'm saying 3, I'm actually selecting the fourth one, right? Because it starts counting at 0. That's the main thing that's going to mess you up when you're dealing with programming languages, and all the programming languages do this. They all start counting at 0 for the computer. You're going to ask a question? No. Okay. Can you guys see it? Oh, yeah, you can. Okay, good. Huh? You're blind. Okay, gotcha. So, well, there's not much I can do about that. All right, so 2 is going to select DNS instead. Let's prove this. If I say save here, going to run it again, and check it out now. It says DNS. So pretty cool. So now we're realizing, oh my gosh, normally we can only store one value in a single variable, but now essentially we have multiple variables within inside of this array variable, and we can store multiple values. Why is this important? Well, for a lot of things, you can do an entire list of things. For instance, we do it in programming where we'll just simply, if you're going to do a very simple implementation of this, I don't want to get real complicated. But as a simple example, you could have an entire list of someone's groceries and then tally it up at the end for all the different price values, run it through a for loop where it loops through all the different array elements, adds them all up, and bam, now you know the total at the end for what they're purchased for all their groceries. Does that make sense? As they scan each one, it goes into a new array element. Bam. And after we're done scanning all the items in, we can run through that loop and calculate the whole entire grocery purchase. Bam, now we have the final value. How does it matter in servers? Well, I could put all those installations for that single server into an array, and I can loop through that array in a for loop, and thus installing every single one of those servers in one statement. Let's do that. Let's not just talk about it. Let's do it. Okay, so we have our lamp here. Oh, look at all these. Check it out. All right, then. Let's start doing that. I am too lazy to go back and forth, so I'm not going to. So we're going to choose this idea instead. All right, I'm just going to paste this in. Simply, I'm not going to keep this. I'm just doing it so I don't have to go back and forth between the two tabs. All right, I'm trying to make my life a little easier other than not at all. All right. So suddenly I'm going to turn this from servers to installs, right? Space MySQL space MySQL dash server space PHP space PHP dash GD so on and so forth. PHP common dash p dash encrypt. I could keep going. Oh heck, why not? Let's do it. PHP dash pair, PHP dash. I'm sorry. PECL dash memcache. PHP dash mhash. PHP dash MySQL. PHP dash XML, and then we have PHP myadmin. Now, so you can start to see why I don't like this method of doing it. It's long. It gets to be, and now you're trying to find something in here, and it's a lot harder. This is visually easier to read when I'm having to go back and check to see if I included an install I wanted or not. So I prefer this method right here. But let's say I don't prefer that method and I want to do it as an array loop instead. Make sense? Okay. So now realize each one of these array elements is literally selecting one of these servers, one of these different, well, yeah, they're servers or install programs that I need to install in here. And I can loop through this now if I wanted to. I can do a for loop. For servers. Sorry, for server. How about this? Do server. Let's have a for install. Server for install. Server. Let's do it like that. Sorry. Capital I. In. Let's call this installs, and let's change the name of this daggone variable over here, right? Alright, let's change that to installs. Now let's put a $sign in front of this thing so we know it. And this is going to be an array though, right? So that's the thing about it. So if I need to access all those elements, I got a couple of different ways of handling this. I can either do an entire listing where I do a star in here, and I'll show you what I mean. But I need to put curly braces around this. This is where it gets nuts. So we put curly braces around it like that. And then inside the brackets, I can have a couple of different ways of saying all the elements. You can say a star, for instance. And what's that's going to do is basically do a whole entire listing as one element. The other thing I could do instead of that is I can do an @ symbol. The @ symbol basically treats it as each one has its own individual element instead. So, you're going to get two totally different setups here, depending on which way you do this. So it's quite interesting as to how this plays out and whatnot. So totally depends is the answer to everything here. For I'm trying to remember how to do the for loop. That is something I would forget. Alright. So basically I'm trying to do like a for fruit here. And then you do it until it's done. That's what I figured. Okay, good. But there's no no semicolon afterwards. Okay, I just wanted to make sure there's no semicolon afterwards. There's not. Alright. So I'm gonna do this one. I'm going to type it, daggone it. Do it until it's done. So start and then I literally come in here like this, copy that, like so, and then I just say $sign install server. And now it's literally going to go through that entire list and install all the servers. And I now no longer need that as a reference. and that becomes my actual script. So it's pretty concise. It's pretty tightly, created or whatnot. So yeah, the highlighting thing can't handle arrays. Like it can't figure out what to do with them. So just ignore the fact that the highlighting's all screwed up. It doesn't know what to do with an array inside a shell script, even though it's set for shell. It's just a little wacky, so it just has a hard time making sense of it. All right, now in order to do this one here, of course, I would need to be root. So let's just do a chmod plus x first here on array.sh maybe, and then let's change users to root. Otherwise, none of the installs are going to work. Array.sh. And check it out. All the installs are failing. It is going through the loop, and it is looping through all these different programs to install them. See that? So it's pretty cool. I'm going to have to hit C a whole lot of times because that's a lot to install. All right, so Control C. So instead of doing, that whole big thing over here in LAMP, instead of going through here and saying yum install all these different ones, what I did in its place was I went in here to this array. I put them into this array variable called installs, and then I came in here and I literally looped through all those with this one little install command to install all those different servers and configuration files.
When you're doing the array, do you have to type it out in a string like that? You can't put it one after the other and then close it out?
In this case, we're declaring it, and so if we're declaring it, we pretty much have to list them all. I don't think we can add it after the fact. That is one of the downsides of arrays, is you can't come back and add them later on. You can wipe over something in there, but I don't believe you can just like extend it however you like, as far as I know, which may be frustrating, but I believe that is the case. Certainly haven't seen an example where you can extend it. So that's kind of the difference here between, if you look at page 1007, you'll see the difference here between the, it says A equals, in parentheses, quotes, $, curly brace, names, open bracket, star, close bracket, close curly brace, close quotes, close parentheses there for assigning it. You'll notice that it took all those names here, Max, Helen, Sam, Zach, and placed them into element 0, the first element in the array. So it took all the elements of the array and literally placed them into a single element, which is crazy. And it just does it as this long list that's separated by spaces. If you use, and then in the other example here, they have B equals, in parentheses, quotes, $, open curly brace, names, open bracket, @ symbol. The @ symbol is the main thing here. Remember the one up above it is a star. So @ symbol here, close bracket, close curly brace, close quotes, close parentheses, then that one's going to actually list all the different elements individually. There, so you can see that. So it's going to, in this case, they're copying the names array into the B array. And they're copying it for all the elements verbatim with the @ symbol. With the star symbol, it's going to copy all the elements from the names array and store it into the first element in the A array. So that's the difference between those two, and it's really important, and that's why you can see the difference. And he even proves it down here when he echoes out A. He says echo space $, open curly brace, A, open bracket, 1, close bracket, close curly brace. That displays nothing. Why? Because there's nothing in that element. Whereas when he echoes out $, curly brace, open curly brace, sorry, A, open bracket, 0, close bracket, close curly brace, here we get the entire list of array elements from names, because all those array elements got stored into the first array element in A when they copied over, because he used the star operator to select it. instead of using the at. Whereas when you look at here, when it echoes out B1 here, essentially, the first element 1, which is the second element in that in B, you get Helen, right? Because it literally copied all the array elements verbatim from one array to the other when he copied it. So that way, when he echoes out B0 there, he gets Max. I'm saying B0 meaning that B is the name of the array variable and 0 is the first is that element, 0 element there on that page. You can see that at the bottom of the page on 1007 on that page there. So that's the difference between a star and an at symbol, and it makes a difference. Okay. How are we doing on time? All right. So what I'm going to do is I'm just going to go over functions, and then I'm going to call it right then and there. And some of this other stuff we'll get into next week because it gets into regular expressions and file redirections. I've already made a video on it, and we'll hit that up next week more so. So this chapter is going to go on for a while. We just can't do it all. There's so much stuff in it. Oh my gosh, there's so much stuff. So we're going to spend time breaking it down bit by bit. We really need to get this down. But let's look at functions, and functions are awesome. Why do functions matter? Well, functions let you basically break down your program into modules. Like I was talking about having things in modules and be able to test it so you don't have problems and headaches. That's what functions allow you to do. Along with having separate files, you can actually break things down into their parts and then test just those parts, and you don't have to worry about the whole rest of the script. So when you're developing stuff, typically you want to break it into functions and test out and develop each function bit by bit as making each piece of the program until you get the whole program. Does that make sense to everybody? That's the easiest and best way to do this stuff. So, for instance, I can rewrite this whole setup here as a function if I like. Alright, so I can say function like so, okay, and then I can space and give it a name, stalling for instance, and then I have to do open close braces here, open like that. Really hate to do it that way, but I'll do it. And then we should have a close one at the end of the function. Yes, good, thank you. Alright, and then we need to tab this over. And the question becomes why? Well, reason why is because then we can actually make sense of what we have here. See, so this, by tabbing it like this, lets us know that this is part of that function. Does that make sense? And that this line right here for the install is a part of the function, and it's also inside the for loop, and that's what's getting repeated over and over again. Does that make sense? So by formatting this, it makes it easy to follow what's going on and understand what's happening. So we want to do that. And then anytime I call this installing function thereafter, it will literally, believe it or not, make it do this whole install loop here automatically. You'll run it. So quite literally, after I set up this function like this, I can just then call it afterwards. I can literally just come in here and say installing, and then that's literally going to actually call that whole process. So that's pretty cool. And normally you can pass in parameters. They're not going over how to do that, which I'm not real happy about. The fact that they're not going over that. Normally that's what goes inside these parentheses is variables. So like I would normally come in here and do something like installs would go in here, and then whatever someone passes in here for an array element inside parentheses would be that list of programs you want to install with installing it, and I can reuse this over and over again for installing things for all the different servers I want, or something like that, for instance. So that's kind of cool, but they're not showing how to do that in the book. But this would run this function. I need to do some tests outside of class here to see how the passing variables would work with functions inside a shell. It's been a long time since I've done it, and there's no way on earth they would have these parentheses if you couldn't do it. So I just need to look into it. I want to make sure this thing's so picky on the syntax. I want to make sure I know exactly how to go about it on this thing, because I know chances are I'm going to do something it doesn't like. Okay. One tip here. It's really kind of interesting. I think I might have gone over it in another video, but if you do like $$ afterwards, it actually accesses the PID number of the program you're running. So for instance, I could say something like cat, or I could just say like echo, sign this right here, literally like that, and I can get access what the process this echo is by the $. You're like, well, that's useless. You're right, it is that way. But if I come in here and said something like copy, and I said like, I don't know, whatever .txt and I copy that to just what.txt, I can do a $, and then I can do multiple copies of this, and it'll give me different version numbers, more or less, based on the PID or process ID number for when the program runs. So this is really useful to administrators. Say you need to run something over and over again and get different versions of it at different points in time. You can automatically put the $$ on it and get different version numbers, more or less, for the file that way. Make sense? You're not going to get the same PID twice, basically. So that's a really cool trick, and a lot of network admins like to use that one. All right, let's save that. Let me see. This should run, ideally. Say should. Should and does are two different things, right? And oh my gosh, it worked. So yeah, my function worked no problem. So just need to look up how to pass variables for it. But yes, this does work if you're just trying to call that time and again. And then of course, whatever I set installs to outside of this function is what it's going to do inside of here. So I can literally come out here, outside of here, and whenever I create an installs array, I don't have to, and I'm just call installing afterwards, and I'm done. If I have this included in something, does that make sense? So then I don't have to worry about it. I can even go down later on, further down here, and redefine what installs is down here, down below it, and then run installing again and install something else. Does that make sense? So functions are cool and they're very powerful, and one of the main things about functions so awesome is that you can do a huge block of code with a single line, and you can use it over and over in different places without having to put those huge blocks of code in all these different places, right? So it reduces the amount of stuff you have to type and how much stuff you have to do work. And not only that, once you get it working, you don't have to keep doing it over and over again. You just call it by that name and then you're done. That makes sense? So that's the other thing about it. Once you test it and it works, you don't have to keep trying to do the same thing over and over again stupidly and have it screw up when you'd already made it work earlier type thing. So basically you code it once and you just reuse it. And that's a really good way of going about stuff, is code it once, reuse it type thing. That's the way you want to do it. So if you do it that way, it saves you a lot of time and headaches and effort. Have any of you guys had the Python class yet? Yeah? Did you guys not go over lists in that class, or arrays? Yeah. Okay, lists are basically the same thing as arrays, only on steroids. sort of like the improved version of arrays, because then you can add elements to them and manipulate them and all this stuff. So they really are quite better than arrays. But this is an array, and this is how it works. Arrays do have a benefit to them over lists, and that lists are less efficient because you can add elements into the list as you go on the fly, but then it has more overhead to do that type of operation. Where an array is really useful is when you have something that never changes. It's the same every time you run it type thing. So if you have something like that, it's really memory efficient because it's not having to support all this other stuff that it doesn't need. And so because of that, it'll run faster. So there's definitely times where you prefer arrays over lists or something like that. So sometimes the lists are referred to as vectors in other programs, but it's all the same stuff basically. Any questions on any of the stuff I went over? Some people are saying too many to count. All right, awesome. Well, I'm not saying it out loud, but I can see it on the face. All right, so that covers all that, and we'll just hit some more of it next week.